Anna. Okay, I'm going to present to you the work that I've been doing in the last while. So I've been working on the development of the residential sector in the new timed Ireland model. And I'll just talk about the methodology that was used in the residential sector, and also just look at some of the results that we've got so far. So first of all, just taking a step back and comparing Ireland to some of the other countries with greenhouse gas targets, specifically looking at the 2030 greenhouse gas targets. We can see here that Ireland is somewhat one of the most ambitious greenhouse gas targets 2030 in the world at 51%. This is compared to 2018 base year. And also, if we include the fact that 34% of Ireland's greenhouse gases are from agriculture, which is pretty hard to mitigate with not much technology options. And also including that Ireland is an island and doesn't have too much power interconnection at the moment. So it makes Ireland quite distinctive and also quite interesting in terms of research. So then just zooming in on Ireland itself and Ireland's climate targets. So the reason we have this 51% target, we had the government formed last year and they said that they would make this a target and also net zero by 2050. What's currently going on in the government is we want to make these targets legally binding and also to set up some sectorial 5-year carbon budgets. So this is quite ambitious. And if we look at Ireland's trajectory, where we have been, so our 2018 greenhouse gases is about 61,000 megatons of CO2. We need to be less than 30,000 in 10 years. We're looking back 10 years or even 20 years or 30 years, we haven't changed that much. So we require a lot of change. And because of this, there was a need to develop a Times Ireland model to give us some insights into how to get to 2030 and 2050, and also to help give some insights on the sectorial 5-year carbon budgets that we needed to use. So my part of the model was to look at the residential side of things. So this schematic here is the overview of the residential structure inside of the Times model. So on the left-hand side, we have our fuels, which is from the Energy Balance 2018, it's our base year. In the middle, we have our energy service types. And on the right, we have our demands, so these vertical lines. So the energy service types are divided between a non-archetype energy service, which is an energy service that is not dependent on the type of house. So for example, in this one, we have refrigeration. We have the total national demand of refrigeration. And that is basically just projected based on the total amount of houses. And on the other side, we have our archetype energy service. All this data from the archetype energy service came from BER database, which I'll talk about in the next slide. But for now, I'll just say we have 4 different energy service types based on 3 different archetypes, detached, attached, and apartment. But also it's worth mentioning, so our space heating that we got from this database, it's from a BER, so Building Energy Rating, which complies with the Energy Performance Certificate under the EU. And one of the calculations they use in it is they assume that all living areas will be 21 degrees. But we know that well-insulated houses or A-rated houses, their living areas are higher, they're about 23 degrees. And the poor-rated houses or G-rated houses, living areas can be 16, 17, or 18 degrees. So we used Ardum SQL to basically recalculate the internal temperatures so that we could get space heating that better reflected what is actually happening in Ireland. So just jumping into the BER database itself. So the BER database accounts for over half of all the houses in Ireland. So it has lots of information, has 11 different archetypes, has loads of different heating fuel types, it also lists the heating system efficiency and lots of other variables. We went through this database, not just us in UCC, but we talked to other universities and other industries, even around Ireland, just to try and filter this data so we could get some of those outliners out of there and better reflect what's actually in Ireland. So some of the other stuff that is quite useful in this database is we have the different regions. So we have the count per region, obviously the BER rating itself, and then also the 4 archetypes that I talked about. They are disaggregated in this database, so we can sort of get a quick overview of the energy rating and the energy service demand, and how much energy is demanded per archetype and per rating. So all this data was essentially put into the model, was filtered first, put into the model, so we could get a good starting point. In terms of the residential decarbonisation in Ireland, 2 of the key components are both retrofitting and heat pumps. And one of the problems that we had to deal with was trying to connect these, because we can't put heat pumps into poorly rated houses because they won't work, but also the fact we don't need to put heat pumps into we don't need to retrofit every house to put heat pumps into it. So showing you an example in the apartments, this is how we've done it. So we have a shallow retrofit and a deep retrofit, and we've applied a cost to that. And then we also have applied a space heating savings. And from that, we can go over and see the requirements for the heat pump. So in apartments, 24.5% of apartments don't require any retrofitting. We can essentially just put a heat pump in there. And then 28.5% will require a shallow retrofit before a heat pump goes in, and 47% will require a deep retrofit. And we've done this based on each archetype. So detached, shown here, it's more expensive, but also we can see here the no retrofitting required is much lower, it's 14.3. So this sort of illustrates the fact that the detached houses are older and of poorer quality than the apartments. And we also done attached, which is quite similar to detached, but a bit cheaper. And then if we just jump into the demands. So I talked a bit about the demands on the schematic. So this graph here shows, the blue shows the existing apartments, the orange, the existing attached, and the green is the existing detached, and up here are the new buildings. So in 2018, we expect to go from about 1.7 million to 2050, about 2.6 million. But also what is worth considering is the amount of apartments that's in the 2018 compared to where we expect the apartments to be in 2050. So we expect a large growth of apartments. And one thing that we want to look at is how this will affect the demand in the residential sector. So I show this graph. So this is the apartment attached and detached. And this is the space heating demand of these 3 archetypes. This is based on the BER database and the internal temperature changes that we've done. So this is what we have, and we can clearly tell that detached has a lot more demand than attached an apartment. It has a poorer stock, and it's usually quite big as well. So then if we look at where we expect the new buildings to be, they're much lower. This is because of the 2021 building regulations have got quite strict. So this is what we're expecting. So we can say that the huge increase in apartments should reduce the demand in the residential space heating. So just jumping into some of the results that we got from this. So for this presentation, I just used one of our scenarios that we used. It's called the low agricultural mitigation scenario. And it's because agriculture is a huge share of Ireland, this is why we've called it low agricultural mitigation. So we're assuming that the agriculture reduces emissions about 3.3% per annum, meaning that industries, energy and processes should reduce about 9%. So in this graph here, we have the different sectors. The yellow is the residential. And in this, the residential greenhouse gas emissions reduced by 75% by 2030 compared to the 2018 levels. Now, the overall target was 51, so residential is expected to go a bit further than that in this scenario. But also what's quite interesting is 2050, the residential is only expected to go 86% below 2018. So a vast majority of the work in the residential sector is required before 2030. And then I just wanted to show the no mitigation scenario. So when there's no greenhouse gas constraints, we still expect a reduction in the greenhouse gas emissions from the residential sector in 2030. This is partly due to the tougher building regulations, but also the model did select a good bit of solar as well. So that reduced the greenhouse gas emissions. So looking at the different fuels that was used in the residential sector. So this graph shows from 2018 to 2050. And one of the main things that jumps out at me at this, again, is the change before 2030. So we can see lots is happening, and then after 2030, it's relatively stable. This again is because of our 2030 target. So some of the key points here, this gray is kerosene, which currently is about 36% of the fuel that goes into residential. It's expected to be gone by 2032. We expect coal to be gone and peat to be gone. We also see a significant increase in solar, and the electrification was jumped a lot too. You can see here that this is the yellow is electricity and the green is the ambient heat, which represents the heat pumps. So we expect that in this results, we got 57% of the energy is from electricity or ambient heat, and where it's 59% in 2050. So again, this highlights the huge changes required before 2030. Just looking at the retrofitting in the results, as I said, the retrofitting and heat pumps were two of the key components in decarbonizing. So in our model, we put a constraint for the maximum retrofits before 2030 to be 690,000. So this represents 60% of the existing housing stock. And then we allowed that to go up to 1.15 million by 2070, which is 95% of the existing buildings. In this, the model decided only to retrofit detached and attached. Apartments weren't retrofitted, This is probably partially got to do with the fact that apartments don't have too much of a demand in space heating, and also they're not significantly cheaper. So when we compare our 2030 retrofits to our 2050 retrofits, again, we can see that most of the work is done before 2030. So in our detached, we have 176,000 deep retrofits and 119,000 shallow retrofits. This grows a bit after 2030, but our attached is pretty much the same. So nearly all our attached buildings are retrofitted before 2030. And just jumping into the results for the heat pumps. So in this, we've seen that 411,000 heat pumps are installed into detached buildings. Now these are both existing detached and new detached. We didn't disaggregate between them, and we got 390,000 in attached and 25,000 in apartments. So we have a significant amount of heat pumps. Ireland's old target was to get a total of 600,000 heat pumps before 2030. These results show 826,000. So there's a significant share. This is a share of heat pumps, both the ambient and the electricity combined, that feed into the water and space heating by 2030. So we expect it to be about 41% of water and space heating will be from heat pumps. So just some of the insights from the residential sector in this new Times Ireland model. We expect, we see that 680,000 retrofits by 2030, 826,000 heat pumps. One thing that I thought was interesting was the similar amount of solar water heating when there was no constraints. So I thought that was quite interesting, because it seems to me like it's a low-hanging fruit. Also, coal and peat are gone by 2030 and kerosene gone by 2032. And there's a high electrification in the residential sector. And what we still have to do, so we've built this model, we've finished it this year, we still have more work to do. One of the things on the residential sector especially is to improve the district heating. Also to disaggregate the BER labels, so between A to G, would be quite useful to explore the optimal sequence of retrofits, and also to explore the gas decarbonisation. In our model, we had gas going down about 20% in 2030. But this was natural gas. So it'd be interesting to explore what would happen if that gas was decarbonised. Would gas still be used more? So that's my presentation. Thanks for listening, and I welcome any questions.
Thank you very much, Jason.
Let's
see, I think there is no immediate question. We will round up soon as well. I have a question. There is a lot of things on the heat pumps I see in Ireland. Do you have it before, or is this something new for Ireland?
We've had it before, yeah. So our climate action plan, which was in 2019, which was the last one we had a total of 600,000 heat pumps to be installed, which a lot of people say was very ambitious, but that was based on old targets. So the model that I've ran, it's like we've come back. I've only shown one scenario, but this scenario showed over 800,000 heat pumps. So it's even more. We're pretty reliant on the decarbonisation of the power sector in Ireland because of wind turbines. So that is one of the reasons why heat pumps is looked upon favourably.
Okay, yeah, because in Sweden we have had it for like 20, I think maybe even 30 years. Heat pumps is kind of being a common thing, but we have had also another power mix compared with Ireland.
Yeah,
water hydro and nuclear. I will send you a question later, I think, also more about, because I'm a bit curious about, or I will ask you, curious about why do some houses, why don't they, is it more that it's not economical to take it into houses that are not retrofitted, or is that an assumption in the model?
To put heat pumps into poorly rated houses.
Yeah, because you were saying like if the houses were depending on the retrofitting level, some houses needed retrofitting in order to put in a heat pump, you said. But is that an assumption, or is that something that the model find out?
That was, so basically that's based on, so in Ireland you have to have a B2 rated house to get it to get a grant to get a heat pump. So that was based on that. And we were talking to some other people, and they were saying, we're trying to figure out what would be the efficiency of a heat pump in a house that's like not a B2, so a bit less. We couldn't get that answer. So
you can come to Sweden and study. We have them in all kind of houses.
Well, that'd be interesting. Yeah.